Hello and welcome back everyone. My name is David Mwita and we are continuing our MPLS configuration series. In our previous video, that's video number 6, we were able to configure MPLS L2VPN, specifically L2VPN of the flavor VPWS. So if you remember, we were able to ensure connectivity between C11 and C10, and we did all that by ensuring that we've configured a virtual circuit between Rwanda PE01 and France PE08. So this is a continuation of that configuration. So today there are no formalities, no introductions, and no slides. We're just going back into the configuration, and our key task here is we were unable to achieve that because of the time. So our key task here is to ensure that this customer CE13 is able to access what we are pretending to be the internet, but in real sense, this particular guy here is nothing but my local PC connected to my local ISP provider. And as you can see, we are doing a DHCP here. This link is connecting to that local PC. As you can see, this is the same subnet as the IP, this IP address that we are using to log into OEVNG. So what we will be able to do here on, in this particular video is very simple. We will just create another virtual circuit between Rwanda PE01 and again France PE01. And after that, we should be able to establish BGP between these two devices. So once we establish that BGP session, what will happen is that the prefixes that this guy is maybe receiving from the internet, we'll be able to also receive them here. But we are simulating a real life scenario here. So we are not actually receiving any prefix from this particular local PC as I've mentioned. What we are doing is we are receiving a DHCP. So we are receiving an IP address via DHCP on this particular physical interface here. So in this particular Portugal IGW, PT means Portugal, if you remember from our previous sessions, we'll be able to configure a static default route pointing to our gateway. Then that's, so we are saying any traffic request coming to me, send it this way. Then this guy will know what to do. That's what we'll be able to achieve in this particular video. Now, the device here is not powered on. The device is not powered on. That's by design, because I wanted to show you guys how to actually ensure that um, you have configured your PC, your local PC, to use your local ISP provider at home to be able to access the internet. So what I'll do here, I will just go and remove this device so that you can follow. Remove it. So it's removed. I can just refresh. There you go. And then now you come and right click. What I'm looking for is this network option. And then here you do management. Okay, you can choose the icon you want to use. Okay, so for us here, we can decide to go with any icon that you would want to use. So let's go with blue, and then you hit enter there. Okay, then you can rename this. You can give it a name. For example, um, let's use internet, and then you save. So once you've done that, remember you can only do this when the device is offline. Once you've done that, you can again now connect these two particular devices. As you can see, it has picked E01, which was the one that we were using earlier. Okay, let's try and resize it here to look more presentable. That's good. So we are getting an IP via DHCP here. Okay. Then let's just lock this lab to disable an unintended movement of the icons or the nodes. So we power on our device, and we can now open the terminal. My devices here are booting up. That's fine. So this is the device that we are currently interested in. And I just want to show you the configuration for the default static route before we move on. So let's just wait for a couple of minutes or maybe a second. I think this is up. So enable show IP interface brief. You can see we are getting an IP address via DHCP. So if we go inside this particular interface, show run interface Ethernet 01, you can see this is the command that I gave. So I'm telling this command that acquire your IP address dynamically, in other words, from the DHCP server, which happens to live in my local PC. Okay, so we can ping our gateway. By default, gateway is .2. So let's see if we can ping, and indeed we can. Okay, now from here, let's see if we can ping YouTube, because now we are connected to that my local PCs, which should be able to, which is my gateway to the internet. So it should be able to take me outside even G and connect to the internet. So let me see if we can ping that. Yes, we can, and as you can see, we are getting the IP address here. We can even ping the IP address. What we are unable to do, that is something that I have not figured out yet, is to do a trace to a public IP address. So it will just hit my gateway, which is this guy here, and thereafter you can see we are not getting any replies, but that's something for another day. What we actually want to achieve is that we want to make sure that once we configure our L2VPN to be up, then CE13 should be able to also ping this IP address. So as a matter of fact, I think we can record this somewhere. Let me just pull out my notepad. Just bear with me. Let's pull my notepad here. Okay. My notepad is opening in another screen, so that's fine. I just want to record the IP address that we for Google. So can we ping, for example, meta.com? Indeed we can. So let's also pick this IP address and record. This is Google, YouTube. Let's record those ones. Like I said, my screen is on another, my notepad is on another screen. That's why you can see it. And lastly, let's ping maybe bbc.co.uk. This is a site, a news site. As you can see, that is the IP address again. So those two are enough for purposes of verification. BBC. Okay, let's move forward now. Now that I've shown you how to connect your Cisco, or this is a Cisco node, but how to connect your nodes to your local PC. Let's move forward, and first of all, before we go on, let's just refresh our mind. Earlier, we were able to do the configuration of L2VPN for C11 and C10 to communicate. Let's just see if we are getting any route now. Show IP route. And indeed, we are getting this OSPF route. Remember, we were also able to configure OSPF. Show run section OSPF. And also the configuration in C11, in C12, 10, I beg your pardon, show IP route. As you can see, we're getting that loopback IP address of CE11. Okay, we can even show you the configuration for OSPF. If you could type that right, OSPF. Yeah, so this is what we were able to configure. And we were able to even do a ping and confirm that we indeed have reachability. So let's ping to 11, and we do. We were even able to do a trace. And I remember I told you what the customer sees is just one hop. And in real sense, we know that the customer is actually using this particular service provider environment to connect to these devices. So from, for example, C10 to C11. So what they see each other, they see each other as a direct connection, point-to-point connection. If you remember what L2VPN, VPWS actually is, it's a basically a virtual point-to-point connection, because these links are not physically connected, but they appear so because of MPLS. So that's verification enough that we need to do here. Let me just quickly show you the configuration that we did. Remember, we were able to do this on sub interfaces. So the interface here is, for example, display current configuration interface ether. That should be 1.7 dot. The VLAN ID here that we gave was, I believe you're supposed to be 1011. Yes. So that's the configuration that we were able to give for the pseudo wire to establish the virtual circuit, and we can actually display MPLS L2VC to see that particular virtual circuit. Let's give our VLAN or virtual circuit ID, and you can see it's up, and the virtual circuit state is up, the session state is up, and attachment circuit, which is nothing but this connection here, is up. And we can even see for how long it has been up. You can see that is how long it has been up for. Okay. How about France, which is the Cisco? The command, a similar command to give you show MPLS L2 transport VC. And then you can give 11 detail. Perfect. So we also have that information that we need here. You can see that it is at least this is how long that it has been up for, and this is all that you need to know about. And we can see also getting labels. So clearly shows that we are doing MPLS encapsulation, and we can show that in this particular interface, show run interface gig 6.1011. Let's build our configuration, and there you go. This is what we were able to give. So that part is done. So right now what we're going to do is to ensure that CE13 can actually, first of all, establish a BGP session with Portugal IGW09, and thereafter we see if we can be able to ping the 3 IP addresses for YouTube, Meta, and BBC. So currently, if you go to CE13, let's open it. CE13. Let's drag it back here. So C13, enable, and then show run. Let's see the configuration we have here. We have the IP address of our loopback and nothing else. As you can see, nothing else. So if you say show IP route, that's what you get. Nothing, we're not learning anything. And then if you say, for example, let's just confirm if we have any BGP configured. Show IP, I think protocol is a command. So we are not running any protocols, as you can see. Nothing is running here. No BGP, no SIS, no SPF, no RIP. Okay, so that's good. Let's go and check Portugal. Show IP route, of course, it will be able to show us the SIS route that we've been configured just for reachability within our MPLS core. So that default IP route that I was telling you about is here. So anything, so 0.0.0.0/0 means if you receive any traffic, so just forward that request to this guy. If I don't have that particular route in my routing table, so that's what this particular configuration here means. So we'll be able to send all the requests to our gateway, which is again my local PC. So that's fine. So let's establish a virtual circuit between Rwanda PE01 and France PE08. So if you remember how we established virtual circuit in the last configuration, again here we'll be using sub interfaces. I want to use a sub interface because this customer here has a VLAN, and the VLAN number is, or VLAN ID is 1300. So let's go quickly to Rwanda because these are things that we've already done, and we go to that interface Ether 1, then we say 1300, so it's a sub interface, and then we can do VLAN type .1q 1300. We can give it a description, and we can give it a meaningful description. For example, IPT customer VLAN 1300. You can even say this one here is AS number 65013. We're fine. So remember, we do a commit. We commit. Okay. And then the next thing that we should do is we should actually be able to establish remote LDP pairing between. We already have one actually. If we can show you that, display MPLS LDP. Yeah, we already have this particular pair ongoing. So there will be no need for us to actually do the remote pair here. So we just go straight into, let's go straight into our interface and configure that cross connect. Okay, so not cross connect, the command is MPLS L2VC, and then context sensitive help. The peer IP of the target is 10.8.8 is the loopback interface of France PE08. And then we are asked to give the identifier of layer 2 virtual circuit, which is in this case our VLAN 1300. Again, these have to match. And lastly, I think these other options here are optional, so we just hit enter here, and then we commit, quit. We can just display MPLS L2VC just to show you that it is not currently up. You see, it is down, right? Because we're not configured the other end. So let's go to France PE08 and configure that. Conf T interface. So the interface here is gig 4, but now we're giving it a sub interface. So it's gig 4.1300. So interface gig 4. First of all, we need to unshut this. So let's bring it up. No shut. I think it was already no shut. Yeah, it was already up, because if you say to show IP interface brief, it has an IP address right here. So it was not shut down. So after that, we now create that sub interface. So encapsulation.1q, then we give the VLAN ID. And then from here, we don't give the IP address here. We now do the xconnect. Let's see, IP address of the peer here is the loopback of Rwanda P01, which is nothing but 10.1.1. I said that the last 3 octets correspond to the device number. So this is 1, so it becomes 10.1.1.1. This is 8, it becomes 10.8.8.8. Okay. Then from here we give the virtual circuit ID, which has to match on both sides. And lastly, we can do encapsulation. Now, this one here, I'm going to do encapsulation.1q, no, MPLS. I'm not going to use a pseudo class like we did last time. So, and I told you the reason as to why we're doing the pseudo class, and we will be seeing that in action when we are doing MPLS traffic engineering. I think that should be our next video. Okay. So let's see. That particular configuration is done. So it's time to do verification. So remember, the reason why we're not getting any notification that maybe our MPLS LDP peer is up is because already, remember, we had already established the peer. As you can see, show MPLS LDP neighbor. Let's do a brief. As you can see, we already have this particular peer up, so there's no need for us to wait for that message. So you can just go ahead and verify in Cisco. The command is show MPLS L2 transport, then virtual circuit circuit, then we give 1300, enter. We can see it's up. That's good. We can even see the details. Those are the details that you need to know. Our output interface should be that port channel 38, which is the logical interface here. And that's the virtual circuit ID, the VC status, and we are getting labels imposed on these ones also. So this is good. This is when it was created as of 43 seconds ago, and the signaling protocol is LDP, and the peer here is nothing but Rwanda P is 01. Okay, and as you can see, remember I told you targeted hello means that this particular LDP peering is not physically, or it's not a local peering, because PE08 and Rwanda PE01 are not physically connected to each other. That's why you can see it's targeted hello. But for the locally connected LDP neighborship or established neighborship, we not see this particular keyword here like targeted hello. So that's good. We can actually go and confirm. Earlier on in Rwanda, you were able to see VC state to be down. So let's go and run this command again. And let's see what we are having here. And you can see this time round it's up, and it has been up for 2 minutes. This is the time that it came up. So these are very good, useful commands just to check your L2 connection or status, or your virtual circuit status. Okay, so we've done that. Now the next thing is to establish BGP between CE13 and Portugal IGW09. So let's go to CE13 and do conft router BGP. Our AS number is 65,013. Okay, we can do neighbor. Our neighbor. Now, I should have given an IP address. Yes, this is the IP address space that we're using. So it's a /24. It's 10.20.0.0/24. So our last octet or the host should be the device ID. So here it should be 13, and here it should be 9. You know what? Before we establish that, let's go. We're not given an IP address. Let's go back. Let's just continue and do that. So let's just say, let's go step by step. Let's go to conft interface E00 no shut. Let's see. And then let's do the sub interface here, because remember we are doing sub interfaces on this particular side, so we also have to do sub interface here. We did a sub interface here, so we also have to do a sub interface here. So the VLAN also, it's good to match that. Encapsulation.1q 1300, and then IP address is 10.20.0.13. It's a /24 or 24 subnet mask, 24-bit subnet mask. We can also give a description and say to ISP 6500. Something meaningful. Doesn't have to be a whole statement or something. So from there, end this and then show IP interface brief. That's okay. Let's go to Portugal. Conft interface. That's E02 no shut. And then while it's up, because it already has an interface, an IP, sorry. So let's get a sub interface. Encapsulation.1q13. And then the IP address on this other side, it should be 10.20.0.9, 24-bit subnet mask. You can also give a description, but this is a lab environment, but it's always very good to give a description. So show IP interface brief. That's okay. Can we ping ourselves first? Good. Now can we ping 13? Nice, we can ping 13, so which means we can now establish BGP peering. So let's go back to 13 and say conft router BGP 65,013. So our neighbor is Portugal IGW09. Remote AS number for this neighbor is 65,000. We can even say software configuration inbound. Okay, and we are not advertising anything. We should advertise. Yes, we had our IP. Yeah, we had it here. So we should advertise this particular prefix because it's ours. So network mask again is 255, 255, 255, 24. Incorrect mask here because this one here should not be a 13, but rather a 0. So let's see our configuration. Do show run section BGP and save your configuration. Very important. Always remember that. And then say show BGP IPv4 unicast summary. We say we are in idle state. By the way, this command is the new when you're disabling the default IPv4 behavior in BGP. So the one that you guys maybe are familiar with is show IP BGP which summary, which will give you the same output. So that's done. Let's go to Portugal. Conft router BGP 65,000. Neighbor is C13, so 13. Remote AS 65,000 and 13. Let's also give soft configuration inbound here. This is not a BGP session, so you can just Google and see what this one is able to do, but I'll be able to show you what it does. Now, remember, inside our global IP routing table, global routing table that is, we have this default route. So we need to be able to advertise this default route back to CA13 because currently, as you can see, our neighborship is up, but we're not receiving any prefixes. So if we ping, for example, the IP address that we had pinged earlier for YouTube was this one here. So if you ping, for example, this particular IP, you will not get reachability because this node CA13 has no idea where to send this traffic to. That's why you're getting 100% packet loss. So to change that, we need to advertise this default route to CA13. So when CA13 receives this default route, it will be able to direct any traffic to our Portugal IGW. And then now, since Portugal IGW has also a default route pointing to our gateway, it will be able to redirect that request to our local PC, which will take it out to the internet. So let's quickly ensure that Portugal IGW is advertising a default route to CA13. So there are two ways to do it. You can either use the network statement and give that particular network. You can just say network 0.0.0.0 and just leave it like that. And if you wait for a few minutes, you should be able to see that particular route being received by, and indeed we do. We can see we have one prefix. Let's quickly confirm which one that is. And you see we have this default route here. So can we now ping that Google IP address? Indeed we can. Perfect. This is what we wanted to achieve. So that's one way of advertising the default route. Another way would be, so let's remove this. Okay, and let's wait for refresh to happen. Let's see if we still have the route. No, we don't. So another way would be, which is what I would recommend, is just say neighbor, because if you do network this command here, it will be able to advertise this default route to all your neighbors that you have. So luckily for us, Portugal IGW09 only has one neighbor, that is C13. That was okay. But you'd want to control what prefixes you're advertising to your neighbor. It's very, very important. So neighbor, and then we give our neighbor IP address 10.20.0.13, and then the keyword here is default originate. And as you can see, there's a route map to control what you can import or how to, you can tag those routes, but that's not the topic of discussion for this particular session. So once you hit this, and also always remember to save your configuration. Now, if you go back to, not sure why you're having this, oh, that's a notification. If you go back to C13 and then do a refresh, you wait for a minute. It normally takes time before it comes up. So I don't want to give you the command to refresh. Let's just wait for BGP to do its thing. BGP is a very slow routing protocol, so compared to OSPF and ISIS. So let's just be patient here. So as you wait for that to come, I think this might be the best time to also show you that what we did in video number 5, where we were focusing on L2VPN, and we were able to just ensure connectivity between C12 and C13, and equally we were able to we were pretending or emulating that this is a server in France, and it's hosting some files or some services that we want. So this user here in Rwanda wants to access those services. So let's quickly take you to PC01 and see if we can be able to ping this IP address here, which is 192.168.14.1. Can we ping? I'm not sure why it's, not sure why it's 14. Sorry guys, 14. Yeah, you can see we can ping. So the next thing is we need to trace and see how our packets or our packet flows. So we go to 12 and then we go to Rwanda P01 and then we go to 7 and then we go to 4, we go to 3, we go to 8, then we finally exit out to 14 and then reach our destination. So this is what we'll be able to we've been able to achieve so far. So that's good. And we'll come back to this when we're doing our MPLS traffic engineering. So I just wanted to show you that that connection or that connectivity is still there. So let's go back to CA13. I think that default route should have been learned. And indeed, you can see we're getting the default route from our ISP, which is autonomous system number 65,000. So again, let's confirm if we can ping that Google, that was YouTube IP, and indeed we can. The next IP we was supposed to do is we were supposed to ping Meta. That's the IP address for Meta. And lastly, we were supposed to ping bbc.co.ke. So can we ping that? That IP address was this one here, and we do. Now, for CE13, unfortunately, it is not able to do domain lookup and give you an IP address. For example, when we're doing the ping in Portugal, let's just quickly do it again. You see this one, because I'm okay, the IP has changed here because I'm connecting directly to my PC, so it was able to do DNS lookup, and then it was for me to know that YouTube uses this particular IP address. But for the CE13, unfortunately, it can't do that. So if you do ping youtube.com, as you can see, that ping fails. Yeah, that ping fails. That ping fails. You just wait for it. It will give you an error or a message, because right now it's attempting to resolve that name to an IP address. So it's not resolving because we do not have any DNS services enabled on this particular node. And we can see you're told unrecognized host or host or address or protocol is not running. So if we ping the IP itself, I think I copied the wrong IP. Let's just copy the correct one. So if we ping the IP itself, so 13, you can see it's able to resolve and we are getting those round trip values there. So guys, that's how you configure L2VPN for real world scenario. In my line of work, this is how this thing is configured. And basically the customer goes through our MPLS infrastructure securely, and then we connect to our internet gateway. IGW means internet gateway, or some literature out there call it international gateway. So once that international gateway is achieved, then whatever we are learning, the routes that is, then we can be able to give them to our customer. But remember, most of these customers, we just give them a default route. We're giving them, in other words, we're giving them a full routing table. So depending on their requirement, that is. So there are those that you can just give them a few prefixes, but there are those that require a full routing table. So again, that is up to you, between you and your customer, to best advise them on what options to go with. Or sometimes, even if you advise them, they already have their mind, made up their mind, so they just want the full routing or internet table. So that has been how to configure L2VPN to be able to give IPT services to a customer. And in our next video now, I think we're going to do MPLS traffic engineering for all these customers, either L2VPN or L3VPN. We'll be able to influence how traffic moves within our MPLS service provider. So we are emulating this to be our production network. So we'll be able to I will be able to come up with how with a PDF file and assume that we have received this request from a customer, that the customer wants this particular, these are the requirements of the customer. So therefore, please do the configuration to ensure that the customer gets what they want. And that is what we will be doing in our next video. Thank you so much. This has been our shortest video. It's about 38 minutes, and I hope it has been worth your time, and looking forward to seeing you again for video number 7. No, or video number 8. This is actually video number 7. Video number 6 was on how to configure L2VPN legacy, that is VPWS, which was what we did to ensure C11 and C10 communicate to each other. And now video number 7, this one, has been to configure L2VPN to ensure that we are giving IPT services to our customer. IPT is nothing but internet protocol transit. So we are the transit as for this guy here, for them to be able to access the internet. So thank you so much for your time. Looking forward to engaging, or looking forward to having your audience again. Until then, take care and bye bye.